Hey guys, I am here and we are going to run through experiment 10.4 here in my kitchen. And what I'm going to do is by doing the experiment, you're going to get some of the measurements that you need. And then what we will do is in class next Tuesday, we will walk through the calculations from this experiment. So all you need to do from what I'm doing here is write down the information that I'm giving you, okay? There's a couple of key measurements, write that down and make sure you bring your pre-lab with you to class on Tuesday, okay? So one piece of information that you need, there's Katie in the background. Say hi, Katie. Hello. One piece of information that you need is the temperature. Now, the temperature in my house is 69 degrees. 69 degrees.
I'll check.
She's checking for us.
70.
Actually, look over on the thing by the yeah. We're getting
In here?
Yep, right there.
Into our 69.
69. That's what I thought. 69. That in Celsius is 20.6. I'm giving you that information. Now, we're going to have to get it into Kelvin. If you want to do that ahead, actually, you should do that. Get it into Kelvin. So 20.6, convert that to Kelvin. Have that as one data point that you're going to have with you in class next week. The other piece of information you need is the mass of the hydrogen peroxide. And I have very carefully measured the mass of this. And there are 110.0 grams. 110.0 grams of hydrogen peroxide. So what we're going to do now is we're going to basically speed up a decomposition reaction. We've got hydrogen peroxide, and when it decomposes into liquid water and oxygen gas. That's just what it does naturally. It does it pretty easily. It doesn't require a lot of energy to decompose hydrogen peroxide. So what we're going to do is we're going to speed that up by adding what we call a catalyst in. The catalyst, you can hear it, is my yeast that I've put in my balloon. Now what I'm going to try to do, just a little insider tip. I've actually done this like 3 times already, and I've had a hard time getting the rate that I want of the decomposition because when I dump the yeast into the hydrogen peroxide, what I don't want is for the reaction to happen so quickly that the bubbles from the liquid water get up in my balloon. So we're going to see what we can do. But here we go. All right, so I'm going to very carefully put a little bit of yeast in my hydrogen peroxide. Now, what you can see immediately is that I get some bubbling that happens. And what that bubbling is the decomposition reaction. And you can also see probably that we're getting a little tiny bit of oxygen gas up here in my balloon. That's the purpose of keeping the balloon on here, right? Is it's going to catch my oxygen gas that is happening as a result of the decomposition. So I'm going to go a little bit slow so that we don't get the yeast in there too quickly. So what I might end up doing here is pausing this for a moment and coming back once we get it all of the yeast in the bottle. So we'll see here. So exciting, isn't it? Oh crap. That's probably too much. We'll see if we can prevent it from expanding too quickly. That's what happened the last time. Doing my best to keep the reaction from becoming out of control. Oh, shoot. It's climbing the walls. What we want is the bubbles to, you can see the bubbles are pretty high in there. But actually, maybe if I don't swirl it around too much, maybe that'll be better. We'll see here. Okay, so, and since I've done this 3 times already, hopefully I'll be able to get a good measurement here. So what's going to happen at the end here, once we get as much of this react as we possibly can, we're going to take this lovely little piece of string and we're going to measure the balloon at the widest part of the balloon, okay? All right, so I'm going to wrap that around the widest part. Looks like my reaction reaction here is actually doing okay. Woohoo! Oh, look at that. That's fantastic. Okay, excellent. I think we're going to have a successful reaction here. So, you can see I still have been catching all this oxygen gas. And then what I'm going to do here is I'm going to wrap this around. Okay. And I have actually already measured that. I've already measured the balloon to where it says to cut it, but I've actually marked on the balloon. Right there you can see, ooh, where'd it go? Right there, see that little dark mark? That's the line of the circumference of the balloon. So what I'm going to do is I'm going to real quick measure this out for you and tell you how wide the circumference of our balloon is. All right, or how long it is. All right, so the other measurement that I want you to take down is I want you to put down that our circumference of our balloon is 41.0 centimeters. So that is exactly what I measured on our balloon. So you need those measurements on your paper in class on Tuesday. So that will be your kind of proof that you've watched the video and that you have, quote, done the experiment. And then what we'll do is we'll walk through the calculations in class on Tuesday. But here is our experiment, okay? And we'll talk about the usefulness and what information we can draw from those calculations once we do them all in class.